Okay, so good evening, everyone. Welcome to the TA session for TDS 4th July. And I'll be taking any questions you have in the beginning. And if you have no questions, then the agenda for today is to cover some of the topics from week 4, go through the graded assignment, and troubleshoot any issues you had with it. And that will be basically what we will be doing for today. Any questions? Okay. Yeah, go ahead, Stan.
No, sir.
Okay. Okay. Right. Let me open week 4. So have you all watched the videos for week 4? Are you familiar with the content of week 4? Yeah, Rajvalit, yeah, Madhurish, yes. Okay, so everyone's happy with I mean, these are actually very straightforward. Only the issue is you'll need Excel to do some of these things, but the similar thing can be achieved with Google Sheets as well. So it's not significantly problematic. Again, regression, this is very straightforward. It's just punching in some buttons and it just works like magic. Forecasting, as long as you have a current version of Excel, these all should work fine. I will go through some examples of GA4 which use these same principles or ideas or tools, and then we can work through those. Again, data analysis with Python. I mean, these are very straightforward things. Reading Parquet files, data frames, pivot tables, all things that you should try and get familiar with, because when you have ROE, not only will you be scraping, but once you scrape the data, there will be some questions that will be asked that will require some manipulation of the data, and that manipulation you will do in your Google Colab or Jupyter Notebook or VS Code or whatever it is. So make sure you're familiar with those tools like the Pandas and manipulating data in the Jupyter Notebook or Colab. So how did y'all find these questions? Were they okay? This is graded assignment 4. Did y'all have any issues with the Parquet and filtering and getting the answers? I mean, anyone want to?
Yeah, I have received the last two questions, the database questions, so that I have handled.
Sorry, say that again, Prajwali.
I am telling that I have received the last two questions that deal with database.
Okay, you had trouble with the last question.
Last two questions.
Okay, yeah, we'll deal with that. But no one has difficulties with these. These were okay. You all managed to get the right answers for these.
Our
Or,
answer are right or wrong, we don't know. But
okay.
I have
Do you,
submitted.
Could
okay.
you discuss the form first, changing that time we require to change it into normal time, a date time format?
Okay, yeah.
Some places I got missed.
Okay.
Yeah,
We'll
can you discuss
we'll
the question number 7 also?
question 1.
7.
7. Yeah, we'll go through it. Yeah. Okay. So since we have some questions about 1 as well, I'll go through this. So if you've got your uh, VS Code or Colab ready, just make sure that the environment is ready for doing these things. Because again, it's not going to be just me typing and doing them. I can do this without any issues. The real learning comes when you're able to do it, right? So I'm just creating a virtual environment like usual. I mean, the reason I do this at the start of every session is because so that you're aware of the process. Some people might find this a little tricky at first. And it also, if any errors throw up, then I'm making the same mistakes and we can learn from the mistakes as well. I've created the virtual environment. I hope you can see my screen, right? All of you can see my screen? Yeah, okay, good. So, right. So, create the virtual environment. Let's create a new file and call it GA4. Okay. And if you look at the question was to get this Parquet file first, right? So let's do that and download the file. Okay. And let me open it and then see downloads. We're in a session today. Okay. And there it is. So normally, if you so we're going to try and solve this using Pandas because the flights Parquet file is gigantic, and if you try to do it in Excel, it most probably will not work. I don't know if others have tried and it worked, but for me, it certainly did not work in Excel. And before we run Pandas, I have to, because it's a new virtual environment, I have to import the Pandas library. So pip install Pandas and choose environment, install the kernel. I'll just make the screen a little bigger as well. Is that better? Yeah, you guys can see it. Yeah, okay. Right. So and we import Pandas, and then the next thing is to try and read the Parquet file, right? So df equal to read Parquet, no, sorry, PD, right? PD dot read Parquet. Okay, and then we do flights. I think it's called. Yep, that's the one. And right, I straight away get an error. Anyone knows why I get this error?
You might not have entered pi arrow.
Correct. So a easy way to diagnose errors is always read what the error says, right? So it says here missing optional dependency, pi arrow. So that's what we need to fix. So we'll do that. Go to the top here and do pip install. Okay, so I'll meanwhile also import one more library because it's just very useful always. So NumPy is a numerical library or mathematical library for Python. Pandas and NumPy are sort of like they are best friends. Okay, it's like a peanut butter jelly sandwich. I mean, I don't know if it's a thing over here, but in the US, that's that's like a killer combo, right? So NumPy and Pandas, they're best friends for life. So whenever you're working with Pandas, it doesn't hurt to have NumPy in there as well. So now let's try and see if this works. It's doing something. Yeah, very good. So it's worked. Now let's look at the data frame, and we can see there's 5 million, or rather 58 lakhs 19,000 rows. So we got the data frame in, and from here on out, it's very, very straightforward. The first thing we probably want to do is, if you look at the scheduled departure time, it's in a decimal, right? It's in float. So we want to convert that into something reasonable. So anyone have an idea of how you could do that? Anyone wants to suggest something? You can open your mic and just give suggestions. We'll try it out. Abdul, Bala, Maduresh, Priyanka, Shivani, any of you guys?
We require to change it into date time format.
Yeah, I mean, that's one way to do it. There is a simpler thing, because if you look at the, let me close this and open the, just give me a second here while I open, I accidentally closed my portal. So if you look at the graded assignment, these are very straightforward. They're only like certain hours and certain minutes, right? So there is something simpler. You could do datetime format, that's fine. And I've covered datetime format in a previous session. But today I'll show you another simple thing you could do, okay? Because just so that we have some variety on how to do things. So I'm going to create a new column, okay? And I'll call it hours. Or actually, before we do that, okay, since you brought it up, Bala, tell me how we can convert this column into date time. We'll do your method first, and I'll show.
Yeah, we require to import date time.
Okay, so import date time. Okay. Then what do we do next?
Particular column we require to convert it into date time by using this.
Okay, so can you either type the command in chat, or let us know verbally what I need to do next? How do we convert the column? Bala, are you there?
Yeah, sir. Sir, you go ahead. Actually, I'm unable to recall.
Okay, no worries. So I'll be using a slightly different method again, just to show that we can do things in different ways. I'm going to create a column called hours, okay? And I'll do data frame. I'll choose the column, and I'll use this apply function. So whenever you want to apply a transformation to an entire column, think of it like a matrix operation. So you want to apply a transformation. So I'm going to apply a transformation. And there is this lambda function. You would have learned lambda function in Python. Basically, it's a function that doesn't have a name, but it will work on every single row of this column. So, and what do I want to do to it? If you look carefully, you notice that we need the hours, right? And the first decimal is all hours anyway. So if I take X, which is the item in each row, and just put int of X. So I did that. Now let's have a look at the data frame. Look at that. There's a column here with the hours, 0 to 23. And that's exactly what we wanted, right? So we can use date time. That's definitely fine. But I thought I'd just show you this nifty little trick you can do also. So you're not dealing with complicated data types. Another thing we needed was sometimes we need minutes as well, right? So we can still do that as well. By no means this is the official way, okay? This I'm doing it for variety so that we can solve many things. It's just useful to learn the apply function and how lambda function works with regards to transformations. So that's why I'm demonstrating this. So again, same thing. There is the decimal part, and this to convert into minutes, you just do a simple mathematical transformation. You take the x, which is the whole float value. From it, you remove the integer part because that's the hours, and then with the rest of the decimal part, you just multiply it into 60. That gives you the minutes. Basic math. This, if you multiply into 60, gives you the minutes, and apply that mathematical transformation to the whole column. So that's done. Let's have a look. And you can see, okay, what went wrong? Something has gone wrong. Int x minus int of x. What did I apply to? Schedule departure. Ah, that's the mistake. So I didn't close the bracket. Right. So I'll have to restart this data frame. Okay, now it's correct. So the thing is, I forgot to close the bracket here. So it multiplied 16 to the negative. That's why it was not correct. But as you can see, now we've got hours and minutes. And now it's very easy to do filtration on this. I mean, I hope you all agree it's easy to do, right? Everyone understood what happened, what we did?
Yes.
I was just showing you how you can do transformations on columns, mathematical transformations, because you will need to do that in, in some things that you will come across in some data sets. So this is a simple mathematical transformation I showed you. Okay.
So could you show that lambda function again?
Yeah. So I'll show you the first one because it's easier to understand. So all it does is I've looked at this particular column and I said apply this transformation. So this lambda, this x indicates each item in this row. So basically what's happening is as it's going through each row, it's taking this value and sticking it in x. Once it sticks it in x, it runs this function. And in this case, I'm just making it integer. So it gets rid of all this and only the front bit is left. And then that transformation is applying to that. And I'm storing it in a new column called data frame hours. And so you can see here it's done that. Same thing I've done here. Again, another lambda function. Take the x, which is whatever is stored in this each row of this column, and then apply this transformation, which is remove the first part of the number, multiply it into 60. So only the decimal is being multiplied into 60, and then make it that into an integer as well. Then you get this transformation. So this has been converted into this and this. And once you do the transformation, I have applied it to a new column. So we get an extra column. So now we don't need this at all. This schedule departure, we don't need it. Right. So the next thing is, in the assignment, you would have noticed that, where is the, so in the assignment, it would have said when filtering, you will get undefined rows. So it's always very useful when you're looking at a data frame to see what kind of values are hiding inside there. Because when you look at this, it looks all well and good, but null values and all these sorts of things can create trouble for you. So the one way to find out is you just do df dot is any. So it will bring up anything that has null values, but you also want to look in any row, any column. So if you use this any, and tell it which axis to look along. So we will look along axis 1. So there's usually only two axes, axis 1 and 0. So if we do this, yeah, and I'm just, so this is the filter. Remember we did filtering last session. So this is the filter, which is find any null values along axis 1 and stick it in a data frame, and so that we can look at it. So now it will pull out any rows which have nan values in it or null values in it. So NaN means not a number. So notice here, even though
axis 1 is column, right?
There is a convention to say column. Sometimes I've noticed, you'll have to look at the documentation. Sometimes there are some places where the function axis 1 will refer to something you don't expect it to refer to. So my recommendation, always check the documentation, but usually axis 1 is column, yes. But there have been very rare instances where it has not been the case. So just check the documentation whenever you're using it, because I myself don't remember always. But typically axis is 1 is column. So if you notice here, it's getting all the nans. But I think in the any function, 1 is row. Okay, because if you look here, it's looking along the row, and it found a nan here, and that's why it has pulled this row up, even though there are values everywhere else. So again, I'm not 100% sure. You'll have to check that out. Maybe you can ask ChatGPT or something. But now that we know there are null values, then we have to deal with those issues. And one of the questions that was asked in this course was, why do we, for these two questions, change the null values to zeros? Now, that's a good question, because typically in statistics, you have to be very careful when you decide to make nulls as zeros. Sometimes null just means null, means there is no information. And if we investigate it, maybe the information will skew the data one way or the other. So it's very risky to change something to zero unless you're absolutely sure that that is the right thing to do. So I'll explain the reasoning why. So with that in mind, right, that do it as, try to retain nulls as far as possible. Of course, it creates some computational difficulties, which is not difficult to get around, but it's something to be aware of. So now I have to give you the rationale for why the first two questions have nulls as zeros. So we'll do a little more investigation on this data frame so that you will understand the rationale. So if I do a filter which says not df dot departure delay is any, so same thing as before. Oh, sorry, df, it should be df. So this tilde at the front, I hope you can see it. This tilde means not. So that's a not operation. So I'm saying not null. So we'll stick this inside some brackets. And I want to check something else also. df dot arrival okay, so this is our filter. I'm going to stick this inside a data frame so we can see what this pulls up. So now we can see exactly what we wanted from the filter, which was, I don't want any NA values in here. I want I want there to be departure delays. I want to see all the items, all the rows where there was a recorded departure delay. And I also want to see if the arrival delay was nan. Now, if the plane left and it was recorded, the delay, then surely it has landed, right? regardless of whether there's an AND here or not. I mean, you all agree?
Yes.
Okay. So in that case, it's a safe assumption to say when there is a NAND that it was actually zeros, because we know the plane arrived, because it has left. I mean, of course, there are some very rare, unfortunate circumstances where that doesn't happen, but for our purposes, we will assume when the plane left and it's been recorded that it's left, it has landed also. So the assumption we'll make here now is because it left, we know it landed. It's not been recorded what the arrival delay is, but it's a good assumption to think that it actually arrived on time. I mean, here it's amazing that it arrived on time, even though it went only 293 miles or kilometers or whatever this was. Maybe it was a very fast aircraft, who knows. Okay. So now let's look at the opposite. Just copy paste from up here. Let's look at this data frame. What went wrong? I thought I copy pasted. Okay. Next. Right. What do you notice in this data frame? Nothing, right? So basically what this is saying is there is no row where the plane departure was NAN and then the arrival had something in it. So this confirms our suspicion. Whenever there is a departure, a plane has landed, and even though it has NAN, it's a good assumption that it landed probably on time. So that's the rationale behind choosing zeros. And then only in that case, you will be able to answer GA4. Now, I didn't make these questions, but I'm just trying to explain the rationale, okay? So don't shoot the messenger.
But this logic is only applicable in this data set.
Yes, correct. And that's the key point I want to make to you. You will have to do it on a case-by-case basis. It depends on, when you're a data scientist, it will very much depend on your data set, your knowledge of the domain, and whether it's appropriate or not. So only do this if it is you're absolutely sure it's the right thing to do. Okay? I hope that clarifies that. Right. So, okay, so now I'm going to do a temporary data frame here, because we will reuse this data frame again and again and make changes to it. So I don't want to have to keep running the whole thing over and over again. So we'll just call this GA41. Okay. So I've stored the data frame we have done processing up there on into a temporary data frame. Okay. Right. Now we can do the changes, which is temp df dot fill na. So there is a function available that any null values you can change it to a 0. So that's what this function does, fill na. It's a useful function. Anytime you have data that's ugly and needs to be fixed, you don't have to fill it with a 0. You can fill it with anything. You can fill it with none also. So that's also possible. Or you can fill it with NumPy, nans, or you can fill it with pandas, NA. So anything you could possibly think of, you could fill it with. But I just wanted to demonstrate that this function exists, and it's a useful function sometimes for data cleaning. So we'll do that. So in place equal to true means take this temp df, change all to zeros, and replace it in the same data frame. So that's what that does. So now if we try to find any nans, we will not find any. As you can see, they're all been filled. Now the first thing that the assignment asked to do was filter flights traveling less than 2,400 miles.
Actually, I didn't drop any.
If you do drop any, some students did not get the right answer. So one thing I checked personally on my end was if you fill it with zeros, do you get the right answer? And I found that filling it with zeros gives you the right answer. And many students on Discourse also found it the same. That if you fill it with zeros, you will get the correct answer. So the assumption is you have to fill it with zeros.
Okay.
Okay. I mean, you can process data however you like, but for the purpose of this assignment, it was to fill it with zeros. That will give you the right answer. So we want to filter by distance. Now this should be very straightforward to all of you. We have done it in previous sessions. So a simple filter applying 2,400 miles. And then what we'll do is there's another filter we need to apply, which was starting at 4 o'clock or 1600 hours and before 1800 hours. So again, very straightforward DF, put the filter. And remember now, because we did the column, oops, oh, sorry, these are all templates. You guys should tell me, man. You should not just keep quiet and watch me type. You have to inform me if I'm making mistakes. Hours greater than or equal to 16. So notice I can do just something as simple as this now, because of the transformation we did earlier. Temp df dot hours, and we want less than 18. Okay, now let's have a look at the data frame. Look at that. Hours are 16 and above, and below 1800 hours. And if you look at the distance also, we had applied the filter first, distance. So this is all below. Still 6,98,000 rows. So now the final part of the question was to make the Pearson correlation. So there's a nice, neat little function in Pandas. Pandas is going to be your best friend, okay, for this term. And in fact, for your data science career. So use this function called COR, correlation. And then you tell it the method you want. And that itself will produce another data frame. So we'll run that. Let's see what it produces. And this will be exactly what you saw in the videos where they did an Excel chart. So it'll make a correlation table with all the columns in the data frame. So you can see departure delay with arrival delay, departure delay with distance. These are meaningless, so you can forget about those. So it makes the table, and then we have to match these with one of the values that was given in the assignment. So 94199 is probably, yeah. So you can see here 94199. So that worked out because we used zeros. If you don't use zeros, most students, I won't say all because I cannot know the answer to that. But many students found that if you don't put it as zeros, you will not get the exact answer. So that worked. Okay. Any questions so far? Okay. It's quite straightforward, not difficult. The key takeaways are how to do transformations, how to do filters again, and you can see the beauty of it. If you use Pandas, you will easily be able to solve most things that you come across very quickly, and that's why it's my preferred method to solve all these questions. Right. So let's look at. So I'm not going to solve this, okay? Because I think it should be pretty self-explanatory how you can do the same thing with this.
Yeah, yeah, yes.
Okay. So next, okay. So this is again, it's the same data set, but some little bit extra is here. So I'll go through some helpful functions you can use for this as well. So the next thing is let's do. Oops. No, actually, I should have made it marked down. It doesn't matter. Okay. So we'll again use the same data set, but because we used a temporary data frame, we can just revert back to it now by using this. So there's another neat little Pandas function called describe. So this is basically descriptive statistics about your table. And you can see it will give you the count, it will give you the mean, the standard deviation, minimum, maximum, and the useful things, the quartiles that we want for this question. So okay, something slightly off with this. Okay, something is gone wrong. Let me, actually this should have worked without me having to reload the data frame, but maybe accidentally I changed something somewhere. That's fine. Right, so let's try this again. Oh, that's bizarre. Oh, no. Okay, let me actually look at temp.ts. Okay, I'm not sure what's happening here. It looks right. Okay, let me do this temp.tf. So I'll try another function, arrival delay median, because one of the things we need for interquartile range is a median, right? So let's try that and see what we get. Yeah, I think that's correct. -5. Okay. And the next thing we will need is Q3, which is so this is where NumPy becomes useful. So do NumPy quantile, and then put your data frame, and it's arrival delay 0.75. So that's your 75th percentile. And if we look at it, okay, something is wrong. I'm not entirely sure what is wrong, because I tried it earlier and it worked without any issues. Is anyone trying it at the same time as me? Have they?
Excuse me. So you earlier changed the temp df to have remove all the nan values, right? But you didn't do that in the df, right? But then you used df when we were filtering according to distances.
Okay, okay,
Then
okay. Yeah. I think that's what it might be. It might be the NaN values are still causing trouble. Yeah, you're right. Let's do that. Good catch. Good catch. Let's see. Maybe that'll fix the issue. Okay, so there's one issue I've noticed. Okay. Yeah. Oh, that reminds me. We didn't do any filtration, did we? For the yeah. Okay. I figured out what the problem is. Okay, if I look at the question, right, before we find the quartile, we do need to do the filtering. So that's something we need to do as well. So I sorry, my mistake. I didn't realize. Okay, so same deal. We'll just copy paste this filters that we have done. We need distance. What I'll do is I'll temporarily not run this one. I want to see what will happen if we do it without it. And then we want the time filtering as well. We'll do that. And we want the upper limit as well. We'll do that. And according to the question, it's 1550. And it's 17 over here. And it is before 18. Okay. Okay, let's give it a spin and see what happens. So I haven't done the what's it called, the NaN values yet. Okay, I'll just check and see how it goes without it. Now if I run the median, okay, that looks more in line with what I was expecting. Yeah, this is fine. This is fine. Okay, so back to where we were. So let me run the descriptive statistics again. Now it should be more sensible, because before there were lots of data, and when it was trying to do the descriptive statistics, it was giving us some unusual things in there. So let's see if it's changed. Okay, that's much better. So when we do the descriptive statistics, now we're doing it on that small filtered set. We can see, for example, this is the minimum, this is the maximum. These are the quartiles. You can see 25th quartile is -4, 75th quartile is 14. And if we run this median on arrival delay, so here in descriptive statistics says it's -2. Here also it's -2. So we know it's correct. Let's do Q3, 14. And that's on what, arrival delay. So Q3, so that's Q3. And you can see here it's 14. That's also correct. So now that you get the quartile and you get the median and all these details from it, you're able to solve this question now. So I'll just quickly type these in. TF dot arrival delay. So we didn't have to remove the zeros for this. Okay, it works without removing the zeros. So we got Q3, we got Q1, and so that's, then we need a lower bound. Let's call it LB equal to Q1. So quartile function, you all know, right? It's 1.5 into the interquartile range, which we didn't calculate. IQR equal to Q3 minus Q1. Okay. And then 1.5 times IQR. And then we need the upper bound, which is Q3 minus 1.5 into IQR. Okay. Then to calculate the outliers, we just need the what you call for it, data that lies above the upper bound and below the lower bound. So the question is, how do you get that from the data frame? Let me just print these so that it's not a mystery. Okay, LB. Okay, I'll show you another interesting. It's not very important, but it's just interesting. So sometimes you get lots of data to work with, and you want to look and see that it's neatly justified and all that sort of thing. So this is a little trick you can use. You can use R justify and give it, say, 7 spaces int to lower, and it just helps when like you're looking at a lot of data. So I mean, in this case it's not going to help us very much, but I just thought it's just something neat to be able to try and use. So you can see it neatly justifies it, right? Justifies the numbers. So if you have a lot of values that you're looking at, it's nice to write justify them so you can make out what's happening. So this is our upper bound and lower bound. Actually, that doesn't look right. Why is it not right? Upper. Okay, let me go back.
What is this RGest of 7?
So what it does is it takes this field and makes it 7 wide, and it right justifies within 7 width. That's what it does. Okay. Okay, now let's see these formulas again. I just want to make sure it's correct. Q3 is quartile, arrival delay, yeah. Q1, yeah. IQR, yes. Lower bound, Q1. Oh, this is the mistake. See, you guys didn't correct me. There's a plus instead of a minus here. Yeah, that's a lot better. Okay, so upper bound is 53, lower bound is 51. Anyone want to tell me how we can get how many? So the question is, if you look at the question, that might help. So the question is, find how many outliers are there given all these parameters using the interquartile range. So how will we do that? Any thoughts, any suggestions how you might do that?
Count those are less than upper bound, lower bound, and greater than upper bound. Number of villages.
Sorry, Prajwalit, you're not audible. Can you speak again, please? Or
Lower than the lower boundary and upper than the upper boundary.
correct. So how would we accomplish that with our data frame?
So greater than 53 and lower than minus 51.
Yeah. So we just put filters, right? So that's exactly what we do. Temp dot arrival delay. Some little interaction is needed from you guys, yeah. Otherwise, it's going to be boring for me also, because it will feel like I'm talking to myself rather than to anyone else. So, and it might be boring for you to hear my voice all the time as well. arrival delay. Because I could have just published this notebook, right? And then you will have all the information ready with you. But I'm not sure that helps your learning. So that's why we do this interactively. TempTF. Yeah. So that's our data frame and the filter. So this is an OR. Okay. This is how you do OR. So we want greater than 53 or less than 51. Agreed?
Yeah. And we
Okay.
record count of
Yes, excellent, good catch. So if I just find the length of this data frame, that's enough, because that will give us the count. Because otherwise it will give us the data frame, which we don't really need the data frame. We just want to know how many are there. So let's have a look. Outliers. So 31,222 is what it says. So let's see if we did it correctly. Yeah. So there's 31,222. So that's how we do it. So I'll just recap this. It's very straightforward again. Once you do all the filtering that's required, which is what we did here, all we have to do then is, this is always a useful function. Hello, can you guys hear me? Am I audible?
Yeah, yes.
Okay. So I'm sorry, my headphones just
Yes, sir.
disconnected just now. Just give me a second, okay? Hello, am I audible?
Uh,
Yes. Sorry about that.
yeah,
Some
yes, you're
equipment
audible.
malfunction. Okay. Right. So this is a useful thing described. It's the same like you get in Excel, basically. It gives you a little table. And then this is how you find the median on any column. And you use so NP here is from the NumPy library. Okay. Remember we had imported it earlier, NumPy as NP. So quantile is a function of NumPy. That's what we used. Yeah, this is GA3, but the same thing I think. Sorry, question 3 of GA. Yeah, and then we found the interquartile range, and we found outliers by putting these filters. Now you notice one thing. Here I individually did the filters. First I filtered on distance, then I filtered for above, then I filtered below. But if you want to chain filters, you can do them this way. You can put and or. Only thing is you have to be careful, because sometimes when you chain them, you might not get the intended effect. So just be very clear about your logic when doing it this way. But this is perfectly valid. If you want and, you just do like this and if you want or, you just put the pipe, and then it gives you an or. Okay. So that covers question 3 and probably question 4. Yeah, that's also an outlier question. So I don't need to solve this, right? It's quite clear, yeah, to you guys? All good? Okay. You guys can open your mic, okay? Because sometimes I cannot see the screen
Yeah, yes.
doing thumbs up or whatever. Okay. So next is how to do what is this? This is regression slope. Sorry?
Sorry, sir, nothing.
Okay. So regression slope, did you guys have any difficulties with this? I think with the regression slope, it was just sticking it in Excel and doing it, right? So that was very easy, I think, the regression slope. Yeah, okay. Basically, all you do is filter out the conditions that were required, whatever, Bangalore, Calcutta, unfurnished, apply the filters on the columns, make a copy of those columns, and then do the regression slope analysis in Excel. So it's very, very straightforward, that was, okay? So I won't spend time on that. If you have doubts with this, just check out the video. I think the video covers these sorts of things. Okay. Okay. Question 7. Were you guys able to do, or did you have some difficulty with question 7? I know some students did have some difficulty with this. Or was it okay for all of you?
There were issues with Excel file. Means after filtering the data out, using the formula in Excel, some people were getting issues because their answers were not matching.
Okay, okay. If you want, I can. Sorry?
Same for me. I had the
Okay.
same problem with this
Okay.
question.
Okay. We will, then we will, I'll demonstrate how we can go about it. And what was someone said something in the chat box. Sir, I had a lot of problems with Parquet. Okay. So the thing with Parquet to Excel, I mean, so yeah. So what the best thing to do for that is, I'll just show you real quick here, is you just use your Pandas data frame to solve that problem. Okay. So I'll just make a quick note here. I'll call it.
Converting to Excel actually hangs it because the data is very vast.
Yeah, so this is what I did. Sorry for me, the very big text. It's better. Right. So what I did is basically I take it into Pandas. I say read. It's not clipboard. Parquet. Okay. And oh, I need the file, don't we? Right. Let me get the file as well. Just give me a second here while I grab it. So house rent. Actually, house rent was a CSV, right? Or am I grabbing the wrong thing? No. Oh yeah, I'm grabbing the wrong thing. Sorry, my bad. Just give me a second, okay? Question 7, okay, this one. Hourly consumption data.
File name must be EST underscore hourly, I think.
Yes, yeah, okay, I got it. Okay, put it in the folder. Okay, good. So back to where we were. Parquet. So EST is the file. Let's read it, and that's fine. You can have a quick look. Make sure. This is another useful function, df.info. It tells you what the contents of the file. So we know there are 1,72,000 whatever entries, and it tells you each row what. First of all, it tells you what the row names are and everything. So what I did was then I just from here I just did df dot to ESV, and then so it exports the file, and then let's open the CSV file. Okay. And something else I like to do is also just change it to an Excel file actually, because then that gives you the full power of Excel. Okay. Now we don't need, okay, there are a lot of rows we don't need, so we'll get rid of those rows. So let me see what we need according to the question. So we need PJME. and June 2007 and forecast for 1st July. Okay, so we don't need all these rows. We don't need that row, and we don't need this row. So these are the only two rows we need for our forecasting. Now what you do is you just use shift control down and shift control side, or if you're on the Mac, shift command down and shift command side. Selects all your data set, and then you just apply the filter. And then if you just hit the up arrow, it takes you straight to the top, and you can do your filtration here. And we want 2007-06, I think it was. Yeah. And we can do it in ascending order. And it brings up all the 720 records. I don't know if you can see it here at the very bottom. It says 720. So 720 lines are there. We need this set. So again, same thing, shift command. So start at the top corner, shift command or shift control down, and shift command right, and you will get the whole set. Copy this into a new sheet. So paste special and say values. So now you got all the values. Now the other thing is this date column is a little bit troublesome for processing. So I'll show you another technique. This will be very useful for you when you're doing ROE or project. Okay, so this is another technique. So we don't need anything actually for the date time to work correctly. We don't need this +000. Okay, so what you do is you go to text to columns. So you go to data, which is up here, and then go text to columns. Select this column and say text to columns, and then use delimited. And our delimiter in this situation, I'm going to say other and say plus, because anything after the plus I want to remove. So notice how it's split it over here. So I'll show you again. Let me go back. So text to columns, you say delimited, go to other. Now notice this is still one column. Okay. As soon as I put the delimiter here, see it splits it. A line comes up here. So now we got the date time exactly in the format we want, and all this rubbish is gone. So we say next, and we can say your date time here, and say year, month, day, and say finish. So now we got a neat date time here, and we got this useless column which we'll delete as well. Great. Now the next thing we want to do is use the forecast. So we use the formula, which is we also need that's the other thing. We need the target date. So let's go back to the first sheet. I'm going to do one more thing. I'm going to say 2007. Actually, before I do that, let me clear the filter. Okay. That's a common mistake. Okay. I do it many times myself. I forget to clear the filter and I keep adding filters without realizing that I'm filtering on top of the filter. So always clear the filter first and then run your new filter. I mean, of course, it depends on what you're doing. Notice I'm also taking July, okay? And there's a reason for this, I'll show you now. So yeah, ascending, yeah, okay. So I'll take this as well. And okay, so to go to the bottom of the data quickly, just press command down or control down. It takes you right to the bottom immediately. And I want to, oh, actually, before I do that, I don't want these top two columns. I don't. Top two row and header row. Just copy this. Copy. Okay. So now I can paste it here. So remember, values only. Paste special values. Let me get the rest of it. Okay, I should have fixed this. I should have fixed this before itself. Right. Sorry. But it's good practice, right? We'll do it again. So let's put this in the new sheet. Same deal. Text to columns, delimited. Yeah. Okay. Before I do that, I have to make a space here. Text to columns. Yeah. Yeah. Move this. Delete. And let's put that back here. Oh, paste special. Oh, what happened? Copy. Oh, man. Format cells, date. Okay. I think what happened is when I did it the first time, did it correctly, but because I did that in between pasting, something has gone wrong. So I'll just redo this section. Okay. I do apologize for the inconvenience, but you run into all these sorts of issues. And remember, when you run into these issues in ROE, then it's very, very painful. So be very, practice is all what I can say. Make sure you practice to do these things so that you don't run into any issues. Just delete, oops, and just delete these sheets and just do that again. Okay. All right, clear the filter. 2006 dash, oh sorry, 2007 dash 06. Sending, copy, values. Yeah, now it's good. So I want to go to the bottom, do the same again. Here filter 200707. Sending order. Copy, paste. Yes, success. So command up, we go right to the top, insert the space and text to columns. Same deal, plus, yes, finish. Excellent. So now we are ready to do the cool thing, which is equal to Forecast.ETS, and we want a target date. So okay, let me go down to 721 so that we, yeah, okay. So this is this forecasting, we want to start from July, so let's do it from here. Equal to Forecast.ETS, and the target date, this is the target date, and we want the values to come from this column. This is the column that we are forecasting. So it is B, oops, comma, B2 to, that's one more thing I need to do. So when we drag and drop, if you don't want the numbers to change, you use this $sign to fix it in place. So it doesn't change at all. Otherwise, what happens is when you drag and drop, these red values that you see here, they also change as you drag and drop things. So this fixes that range in position. So it never changes even if you drag and drop it. So B $721. You can see this red column. So this is the values that we are using for prediction. And then timeline. Timeline is everything about this. So again, same thing. This time it's $A, $2, and $A, $721. Okay. The rest you can just leave it to the defaults. And I'll just make this a bit bigger so you guys can see it. So that was the formula. Can you see this clearly? Is it visible? Just open your mics and tell me if you can see it.
Yeah, yes, it is.
This formula. Yeah?
Yeah.
Okay, great. So it made a prediction here. And we wanted to predict, if we look at the question, we wanted to predict 11 o'clock. So let's do that. So now if I drag and drop till 11, we'll get some values here. Now, the key thing to remember is, because I put these dollar signs, this didn't get affected. Now watch if what happens if I didn't use these dollar signs. I'll copy the same thing here, okay? And instead, I'll just remove the dollar signs. Just use the normal ranges which you usually use when you're working with Excel. Okay. What happened? Okay, let me copy this here. Target date, I want it to be that one. Okay. C2, oh, not C2. But you notice something, when I copied and pasted, everything moved. And that's exactly the reason why we should use dollar signs. And this should have been the timeline, which was A and A. A722, B2, B2, this I think. I'm not sure why that didn't work. Okay, and regardless, that's the reason we use dollar signs, so that when you move the cells around, it doesn't shift the ranges everywhere. So that's why if you look here, this formula still remains the same, but just this front target variable is changing, because as the cell is moving down, the target variable is automatically changing to reflect that. So let's see if this is correct. 35541. 35541. Yeah, 35541.55. Yeah, 35541.5. Yeah. So that's how it works. This first value is your target date that you want a prediction for. This second set of values is the actual value that is being predicted. So that's what you're getting these numbers out. And this is the previous timeline from where these values came. So these are basically the labels, and then these are the item in your series that gives you those labels. Okay, is that clear? I think it's clear, right? I hope my explanation was not confusing.
Yeah, it's clear.
Okay. But remember, the important trick was to do that text to columns, okay? So that you get a nice, clean time series data for Excel to work correctly. That was the trick to it. Did anyone come up with any different method of doing it?
I just filtered the data in Pandas and then used Excel rather than.
Yeah, of course. Yeah, definitely. You can do that. I mean, my preference is Pandas, but the reason I showed this is just so that you guys have something different to work with as well. So it's giving you as many tools as possible to solve the problem. So that's the reason. Okay, let's see. Old JAS. I was getting wildly different results from Python and Excel. Yeah, I mean, it's possible. If this data set is too large in Excel, then sometimes that can cause issues. So using Pandas to filter down the set is very, very useful. So in my case, it worked okay. But yeah, that would be the best way to do it. Filter down the set as much as possible. And this Forecast.ETS is a closed source formula. So that's why we can't we don't know what Microsoft is using to make these predictions. They have not shared the details with everyone. Okay, so that's why this is the way it works in Excel. Okay, so that's save this file, and let's go back to our assignment and see where we are. So now you should be able to solve questions 7 and 8. They're both basically similar types of questions. Then, okay, SQL. So 9 and 10. I presume some of you might have had some difficulty with this, but again, it's not very difficult because they didn't give you a very complex data set. So we'll go through that. Right. So there was a notebook that was shared in the data analysis part of week 4, and I'll just show it here quickly. So I'll not be using the notebook, but it has all the things you need in order to be able to do the analysis. This one, I think. So have you all seen this notebook before?
Yeah, I opened it.
Okay, great. So the important bit from here, there's only a few things that are important, okay? Forget about this, okay? That's not important. All you need is, of course, the libraries. You need the libraries, and you need the this connection string. Okay, that's the first thing that you need. Then the next thing you need is to read the query into your to read the query from the database, and so you will need this function. Basically, it's this line. Basically, it's this function was just something that was created for convenience. So that's all you need. Those are the only things you need in order to make this work. So let's do that. Okay. This is, I think 9 or something, isn't it? Okay, so we need some new libraries. So we'll do that. Install alchemy. And then we need so there's also you need a driver, okay, a library that specifically helps to SQL Alchemy to connect to the database. So this is also a requirement. So it's called PyMySQL. So both of these are required. Okay. Then, as usual, we have to import the libraries. So SQL Alchemy. Let's see something. And then we need to use, this is exactly the stuff that was in that notebook, okay? So you can just copy it from there. And then the first part of the string is the type of database and driver you would use. This will vary from database to database, okay? So this one is, this particular database uses this connection, so that's why we need to use this driver set. And then these parameters that I'm putting in, they come from the site that was given to you. So I'll just show it to you so that you know what it looks like. So if I close this and go back to our assignment. Okay. Yeah. So if you go to the bottom over here, it tells you all the things you need for being able to connect to the database. So that's what we're going to use. So the connection was using the login is guest, and this is the database server itself. Relational at db.relational data.org, and then you need to give the name of the database. So in this case, it was called REST base. If you look in the notebook that was given, that was looking at a different database. So this site hosts several kinds of sample databases. And on the notebook that was provided, it was called posts. So they were looking at a posts database, but we are looking at the REST-based database, which is the restaurant database. Okay. So I think that's correct. I'll just double check here. Sure, the string is correct. Yeah, it's exactly the same. Yeah, okay. So let's store that variable. And then the only thing we need to do now is run the queries. So what I'll do is read SQL or SQL. So actually, it's usually called SQL. Okay, that's the official nerdy way of calling it. Oh, right. We need the. I made a mistake. Sorry. We need the other bit as well. Just give me 1 second. Okay. Okay, so what happens is we put our query here in this SQL string, and then we run pd.read SQL, and we put the query in here, and then we give it the engine connection, and then all it does is connects to the database and spits out a data frame for us, a nice, neat little Pandas data frame, which will enable us to work on the files that we want. So if you look at the question said, the question say, the question said, okay, so we want count the percentage of restaurants that serve barbecue food type in each city. So first of all, we need each city, and we need to know how many of the restaurants in each city serve barbecue food. So not only do we need each city, we need all the total restaurants in each city, and we need all the ones in that city that do barbecue. So then that ratio is what we have to count. And then once we know the ratios of each one of them, then we have to see, then the question is, which one has a higher ratio than San Francisco? So it's a little bit multi-step, but it's not too difficult. So, so what we'll do is, so this part, SQL is itself something that's covered in DBMS. And I think a little bit in MAD1, they talk about SQL queries. It's an entire subject in itself. Being a database administrator is a total job in of itself. So we don't in this course expect you to become experts in SQL, but at least you should be familiar with some basic simple queries. So remember, we wanted all the cities, right? So I'm going to show you the data set here. So if we go up here, you can see this is how the database is organized. There are 3 tables, and those tables have fields in them, and we want to get all the cities and their restaurants and the food type. So which of these 3 tables will give me that information? the restaurants, the cities, and the food types.
General information for food type.
Yeah, yeah.
Geographic for city.
Mm-hmm. But why geography for city and not general info for city?
Yeah, general info also we can. Right?
Yeah, yeah. We can get from here also, no problem. But if we think about the structure now, every city, I know it's unusual, but every city may not have a restaurant, right?
Okay.
Yeah, I mean, when it says city, I know we think of big cities, but it could be like a little village, and they call it a city. Okay, it could be just like a one street village, and there may not be a restaurant in it. Whereas every restaurant will definitely be in a city, right? Agreed?
Yeah. Yeah.
Yeah. So that's why, that's the reason I will use only this table. Okay. But just for as an exercise, we will have a look at this also, just so that we can run some simple queries. So the way you find information from a database is you use this language. So you say select, and the question is select what. So we want city. Okay. And then the question is from where. So there were three tables, and you have to tell it from which table you want the city. So as Bala suggested, we'll use the geographic table and see what we get. So geographic, yeah. Okay, and let's see what happens. So this is the SQL statement. It's just, we are just put the string in that variable there, and now we'll run this and see what we get out of the data. So initially it might take a little bit of time because it's connecting over the web to this, authenticating and all that. And it seems like it got a data frame. Let's look at the data frame. Look at that. Isn't that amazing? It just got all the cities from that table. Fantastic. Now, the next thing we wanted was, we wanted restaurants, right? We want restaurants, we want food type. These three things we wanted. And actually we can get all that information from just one table. And that was the general info table. So let's just change this SQL statement a bit. Okay, say select star. So star means everything. So get everything that you, when I mean everything, everything as in every column in that table. So that's what star means. And this time instead of geographic, we will say general info. Let's run it and see what happens. Okay. Now let's look at the data frame. Great. That's excellent. So now we got all the information we need for solving GA 9 and 10 is in this. I know that seems incredible, but that's true. Okay. So now we want to, okay, first thing I'll do is, we want, let's see, okay, we can do a simple test. That's what we'll do. So you remember that in the assignment, it says San Francisco has 1,240 restaurants. Now, better we check that, right? Because otherwise our ratios will be wrong. And some students in discourse were like, no, San Francisco has less, San Francisco has more. Better to make sure our database is correct before we try to solve it. So now that we have a nice, neat data frame, it's very simple to solve, right? So all we have to do is use a filter like usual, df dot city equal to San Francisco. I think that's Francisco. I think that's correct. It's over here as well. Okay. And then stick that. And we just need the length of it, right? So let's see. Length. Ha! 1240. Perfect. So we know that's correct. Now, the next thing is we need to find a way to find how many total restaurants are there, not just in San Francisco, but in each and every city. Anybody can give me some suggestions. Now, there's no one right way to do it, okay? There are many, many ways we can do this. So, but I want some suggestions from you guys. Hello, anybody home?
Can you repeat the question?
Okay, so the question is, we want to know what the total number of restaurants is in each and every city. How do we go about doing that? We got a nice data frame which gives us all the information we need. I want to know, how do we find out the total number of restaurants in each city?
Can't we use group by city to get that?
Excellent, excellent. Who was that? Who said that?
Shivani.
Shivani. Okay, yeah, fantastic, Shivani. Brilliant idea. Okay, that's exactly what I would have done. So so this is a new function. It's called group by. So if you want to group things by certain columns, you can do that with this function. So, and you can give multiple group bys, okay? So multiple levels are possible. So, but we wanted only a count of all, what you call for it, the restaurants by city, grouping by city. Because if you look at these columns here, so for example, San Francisco will have this restaurant, San Francisco will have Hellman restaurant. So like that, it will have many, many restaurants. So we wanted all San Francisco to be in one group. So that's what we'll do, group by city. And then the next thing we want is, so this will spit out a data frame, okay? And then next thing we want is, we want a count of all individual rows that the group by has. And then the next thing what I want to do is, I want to also reset the index, because the reason for that is, it will create a new table, and that new table will be very different from this table. So I don't want the index to use the same old index that is there. So I'll reset the index. And then this table had lots of useless things that we don't need also. We don't need to know the names of the restaurant, and we don't need the reviews. And what else? We don't need label, we don't need review. And yeah, and I mean, and the question I was asking was, I only want to know the total restaurants, right, in each city. So we don't need food types. So we'll drop all those things. So reset the index, then I'll say drop. This is another function. And now I'll put the columns I don't want. And axis is 1, because axis is columns. I want to drop these columns. And like earlier, I think, who was it? Bala, I think, said 1 is columns. So usually that's the case. Let's hope there's no mistakes in this. Aha, nice, nice. Look at that. So it grouped by city and tells you Alameda has 130 restaurants, Alamo has 12, Albany has 38, Alviso, whatever. So, and we can see there are 167 cities, and these are all their details. So that's so we can stick this in a data frame. City. Yeah, it's the same. Okay. The next thing we wanted to know was, we want to know.
Show that SQL, sir.
The SQL was very simple. I just got the whole table. And then we do all the processing in Pandas because Pandas is so easy to process things with.
Yeah, last command.
Oh, this one. Yeah.
Yeah.
So we grouped by city. So this is the data frame. We grouped it by city. And I wanted a count of all the rows that you get. Then I dropped the index because we're getting a new data frame here, so that the index gets reset basically. Then I removed the unnecessary columns. That's all I did. Okay.
Yeah.
Okay. And then we got this neat little table. So one part of the solution we have now. We've got total number of restaurants in each city. Now the next thing we want to know is within each city, we want to know how many barbecue, I think was the question. Let me see. I mean, it'll be different for different people, but let's see this one. Yeah, barbecue. So now we want to know how many barbecue restaurants were there in each city. So the question is, how do we accomplish that? Remember, we still have access to the main data frame, this table. We've got this information. Okay, so two things you need, right? We need to group by city, but it's probably useful to group all the restaurants also, right? Because you look like this, like Sunnyvale, see, it will have 2 or 3 or maybe more Afghani food type restaurants, or Indian or whatever it is. So we can do 2 levels of grouping. You can say group by city, but also group by the food type that they're doing. Yes, agreed? Makes sense? I mean, you guys need to speak because I cannot see your thumbs up if you're doing thumbs up.
Oh, yes, sir.
Okay, good. So far you guys are not confused, right? You understand what's going on, right?
Yeah.
Okay, good. So city, so let's call it city food. So we'll do a group by again. And this time we'll do city and we'll do food type. So 2 types of grouping. You can, okay. And again, same thing. We want to count of all the rows that come out. This is also another table. So we'll reset the index and then drop anything useless. So useless things will be, we don't need to know the restaurant names and we don't need to know any reviews also, we don't care about. And these are columns we are dropping, so axis equal to 1. Hope this works. Okay, something happened. Let's have a look. Hey, isn't that nice? So Almeida has 4 American food type restaurants where they serve American food, 2 that serve bagels, 2 that serve breakfast, 5 that serve burgers, 10 cafes. I mean, this is cool, isn't it? It's awesome. Yeah, nice. Okay, so that's good, but this is still not enough, right? We actually want restaurants that serve barbecue food only. We want to know the number of restaurants that serve within each city that serve barbecue food. So we can again do the same thing, but this time instead of on the whole data frame, we can just do it on this itself, right? So I'll just call it BBQ, say city food, dot food type equal to barbecue. So this time we are working on the small set only because we have all the information in here. Okay. And then we'll drop useless columns we don't want. Now you'll be thinking, "Hey, why are you dropping food type?" Because actually we just filtered here all barbecue restaurants, right? So we don't need to know it's barbecue. We already know it's going to be barbecue, but we just want the numbers. So if I have a look now, so Aptos has 1, Benicia has 2, Berkeley has 3, Oakland has 7, and look, there's San Francisco. San Francisco has 8. So now we have all the restaurants, all the barbecue. How many barbecue restaurants are there in each restaurant? So we got both the pieces of information we needed. We got the total number of restaurants in each city from the city total data frame, and we got the barbecue restaurants in each city from the BBQ data frame. Simple, right? That's pretty good, right?
Yes.
So now you should be able to solve the question, right? Which is just divide one by the other. And that's just simple math, right? So I'm not going to do that, okay? That you guys can do. It's a very straightforward exercise to divide one by the other and programmatically and find the answers for your graded assignment. That was this one over here. So all you have to do is find the percentage of restaurants that served barbecue food in each city. So you divide one by the other, and then you find out how many of them had a higher percentage than San Francisco. So that's just basic math, and that solves 9 and 10 basically. Once you process the data, then it's very simple, and it's that's all. That's all that's there to it. But you can, I hope you can appreciate the power of Pandas to do nice filtering and be able to solve things in a nice, neat way. Could this have been solved completely in SQL? Yes, it could be, but the SQL commands can be complex in its construction. So that's why I didn't want to confuse people and show that. But when you do DBMS, you'll be able to construct fairly complex queries, and you won't have to do all these filterings and things. But it's an art and a science as well when you do construct SQL queries. And there are, the only problem with SQL queries are you can have unintended side effects, and that only comes with experience. So that's why Pandas is a fairly safe way of going about it. Any questions? Was everything clear that we discussed today? I hope it was clear.
Yeah, it was great.
Okay. Did you guys learn something new, or did you know all this stuff already?
I didn't know about SQL stuff, so it was
Okay.
very helpful.
Okay. Yeah. SQL, you can, in fact, there are some books that teach you just pure SQL. I used to have a book many years ago, and if I manage to find it, I'll give you the details of the book. But that book teaches you pure SQL. It doesn't. It's not dependent on database. It's not dependent on any other thing or any other language. But you will be able to construct very good queries from it and be able to do some very advanced things with databases. So if I find that, I'll let you know. But there is also in the DBMS course, there's a book written by the professor of that course itself. That book also I highly recommend. In fact, that book, I would say it's good to have a physical copy of that book if you can afford it. It's not too expensive. It was written by IIT Madras professor, but it was in conjunction with some professors from abroad. Excellent book to learn databases, and highly recommended. So that's what I would say about if you want to get into SQL.
Thank you, sir. I have a question from the previous assignment. Can I ask that?
Yeah, okay, sure.
Like we did in the Visual Studio Code, we get a data frame. Can I share my screen?
Yeah, of course. 1 second. Let me just stop sharing my screen. Okay, go ahead.
Okay, 1 second. Is the screen visible?
Yes, it is. Yeah.
So it was the same question. I have a difficulty in question 3. We got the data frame.
Yeah.
Originally, like in the previous session,
Yeah.
this was the data frame that we
Okay.
got in this format.
Okay.
And for the question 3 and question 4 are the same type, but I'm getting incorrect answer for the question 3, but right answer for question 4. I don't know why. So
You're getting incorrect answer for question 3, but right one for 4, is it?
yeah,
Okay.
I've also pasted it on this course. I think
Okay.
this was the question 4 I have to get for the blog and for the Sunday.
Okay.
And I constructed a dictionary, and it gave me the wrong answer for that. It gave me 67, but the answer was 65. 1 second. Oh,
Okay.
here. I
Yeah.
constructed a dictionary based on the converting it into integer for the
Okay.
hours, and it gave me 67, but answer was
Okay.
65.
Do one thing. Share this notebook in your Google Drive. If you can share this notebook, then you'll have to
So,
put. Yeah.
how to share it?
So what you can do is, if you upload this file into Google Drive,
Okay,
because
okay,
then I can have a look at it and see what the issues.
okay, okay, I'll do that. Okay, thank you.
And you can put my email address for sharing. So in Google Drive, just add me as a viewer, then I can download the file and have a look.
Okay, okay, thank you.
Okay. And I'm not sir, okay? I'm just a student like you guys.
Sorry.
Yeah. Okay. Any questions about this week or previous weeks, or any just general questions? I mean, I'm aware that you guys have, some of you will have quiz as well. So I won't keep the session much longer. So it's already nearly 10. Okay. If there are no questions, then I'll close today's session. Okay. Okay. Thank you. Thank you guys for being here today.
Thank you. Thank you.
Thank you.